Plastic recycling is the process of recovering scrap or waste plastic and reprocessing the material into useful products, sometimes completely different in form from their original state. For instance, this could mean melting down soft drink bottles and then casting them as plastic chairs and tables. Plastic recycling is largely a misnomer since plastic beverage bottles are never reformed into new beverage bottles. This requires virgin plastic. There simply is no cycle involved with a recycling of plastic beverage containers. Plastics are also recycled during the manufacturing process of plastic goods such as polyethylene film and bags. A percentage of the recycled pellets are then reintroduced in the main production operation. This closed-loop operation has taken place since the 1970s and has made the production of some plastic products amongst the most efficient operations today. Challenges: compared with other materials, such as glass and metal, plastic polymers require greater processing to be recycled. Due to the high molecular weight of their large polymer chains, plastics have a low entropy of mixing. A macromolecule interacts with its environment along its entire length, so total energy involved in mixing it is largely due to the product side stoichiometry. Heating alone is not enough to dissolve such a large molecule, so plastics must often be of nearly identical composition to mix efficiently. When different types of plastics are melted together, they tend to phase separate, like oil and water, and set in these layers. The phase boundaries cause structural weakness in the resulting material, meaning that polymer blends are useful in only limited applications. Another barrier to recycling is the widespread use of dyes, fillers, and other additives in plastics. The polymer is generally too viscous to economically remove fillers, and would be damaged by many of the processes that could cheaply remove the added dyes. Additives are less widely used in beverage containers and plastic bags, allowing them to be recycled more often. Yet another barrier to removing large quantities of plastic from the waste stream and landfills is the fact that many common but small plastic items lack the universal triangle recycling symbol and accompanying number. An example is the billions of plastic utensils commonly distributed at fast food restaurants or sold for use at picnics. The use of biodegradable plastics is increasing. Processes: before recycling, most plastics are sorted according to their resin type. In the past, plastic reclaimers used the resin identification code, a method of categorization of polymer types, which was developed by the Society of the Plastics Industry in 1988. Polyethylene terephthalate, commonly referred to as PET, for instance, has a resin code of 1. Most plastic reclaimers do not rely on the RIC now. They use automatic sort systems to identify the resin, such as near-infrared technology. Some plastic products are also separated by color before they are recycled. The plastic recyclables are then shredded. These shredded fragments then undergo processes to eliminate impurities like paper labels. This material is melted and often extruded into the form of pellets which are then used to manufacture other products. Thermal depolymerization. Another process involves the conversion of assorted polymers into petroleum by a much less precise thermal depolymerization process. Such a process would be able to accept almost any polymer or mix of polymers, including thermoset materials such as vulcanized rubber tires, superation of wastes and the biopolymers in feathers and other agricultural waste. Like natural petroleum, the chemicals produced can be made into fuels as well as polymers. A pilot plant of this type exists in Carthage, Missouri, United States, using turkey waste as input material. Gasification is a similar process, but is not technically recycling, since polymers are not likely to become the result. Heat compression, yet another process that is gaining ground with startup companies, is heat compression. The heat compression process takes all unsorted, cleaned plastic in all forms, from soft plastic bags to hard industrial waste, and mixes the load in tumblers. The most obvious benefit to this method is the fact that all plastic is recyclable, not just matching forms. However, criticism rises from the energy costs of rotating the drums, and heating the post-melt pipes. Other processes. A process has also been developed in which many kinds of plastic can be used as a carbon source in the recycling of scrap steel. Applications: PET. Post-consumer polyethylene terephthalate containers are sorted into different color fractions, and baled for onward sale. PET recyclers further sort the baled bottles and they are washed and flaked. Non-PET fractions such as caps and labels are removed during this process. The clean flake is dried. Further treatment can take place, for example melt filtering and pelletizing, or various treatments to produce food contact approved recycled PET. RPET has been widely used to produce polyester fibers. This sorted post-consumer PET waste is crushed, chopped into flakes, pressed into bales, and offered for sale. One use for this recycled PET that has recently started to become popular is to create fabrics to be used in the clothing industry. The fabrics are created by spinning the PET flakes into thread and yarn. This is done just as easily as creating polyester from brand new PET. The recycled PET thread or yarn can be used either alone or together with other fibers to create a very wide variety of fabrics. Traditionally, these fabrics are used to create strong, durable, rough products, such as jackets, coat, shoes, bags, hats, and accessories, since they are usually too rough for direct skin contact and can cause irritation. However, these types of fabrics have become more popular as a result of the public's growing awareness of environmental issues. Numerous fabric and clothing manufacturers have capitalized on this trend. Other major outlets for RPET are new containers produced either by molding into bottles and jars or by thermoforming a PET sheet to produce clamshells, blister packs and collation trays. These applications used 46% of all RPET produced in Europe in 2010. Other applications, such as strapping tape, injection molded engineering components and even building materials, account for 13% of the 2010 RPET production. PVC. Collection and recycling schemes for the PVC waste stream are managed through Vinyl in Europe, which reported the recycled tonnage as follows: Profile 107,000 tons. Flexible cables 79,000 tons. Pipe 25,000 tons. Rigid films 6,000 tons. And mixed flexible 38,000 tons. Vinyl states that of the recycled material, 75% is for floors, 15% for foils, 5% for traffic cones, 3% for hoses and 2% for other applications. One of the recycling processes is the vinyl loop to Xyloop, used for solvent-based mechanical recycling. It involves recovering PVC plastic from composite materials through dissolution and precipitation, and is a closed-loop system, recycling the solvent and regenerating PVC. It offers a major ecological benefit, as vinyl loop-based recycled PVC's primary energy demand is 46% lower than conventional produced PVC. The global warming potential of recycled PVC is 39% lower, a significant reduction in the ecological footprint. HDPE, the most recycled plastic, HDPE or number 2, is downcycled into plastic lumber, tables, roadside curbs, benches, truck cargo liners, trash receptacles, stationery and other durable plastic products, and is usually in demand. P.S. Most polystyrene products are currently not recycled due to the lack of incentive to invest in the compactors and logistical systems required. As a result, manufacturers cannot obtain sufficient scrap. Expanded polystyrene scrap can easily be added to products such as EPS insulation sheets and other EPS materials for construction applications. When it is not used to make more EPS, foam scrap can be turned into clothes hangers, park benches, flower pots, toys, rulers, stapler bodies, seedling containers, picture frames, and architectural molding from recycled PS. Recycled EPS is also used in many metal casting operations. Rastra is made from EPS that is combined with cement to be used as an insulating amendment in the making of concrete foundations and walls. Since 1993, American manufacturers have produced insulating concrete forms made with approximately 80% recycled EPS. Other plastics, The white plastic polystyrene foam peanuts used as packing material are often accepted by shipping stores for reuse. Successful trials in Israel have shown that plastic films recovered from mixed municipal waste streams can be recycled into useful household products such as buckets. Similarly, agricultural plastics such as mulch film, drip tape and silage bags are being diverted from the waste stream and successfully recycled into much larger products for industrial applications such as plastic composite railroad ties. Historically, these agricultural plastics have primarily been either landfilled or burned on-site in the fields of individual farms. CNN reports that Dr. S. Madhu of the Kerala Highway Research Institute, India, has formulated a road surface that includes recycled plastic, aggregate, bitumen with plastic that has been shredded and melted at a temperature below 220 degrees Celsius to avoid pollution. This road surface is claimed to be very durable and monsoon rain resistant. The plastic is sorted by hand, which is economical in India. The test road used 60 kg of plastic for an approximately 500 meters long, 8 meters wide, 2-lane road. The process chops thin film road waste into a light fluff of tiny flakes that hot mix plants can uniformly introduce into viscous bitumen with a customized dosing machine. Tests at both Bangalore and the Indian Road Research Centre indicate that roads built using this KK process will have longer useful lives and better resistance to cold, heat, cracking, and rutting, by a factor of 3. Recycling rates. The quantity of post-consumer plastics recycled has increased every year since at least 1990, but rates lag far behind those of other items, such as newspaper and corrugated fiberboard. Overall, U.S. post-consumer plastic waste for 2008 was estimated at 33.6 million tons. 2.2 million tons were recycled and 2.6 million tons were burned for energy. 28.9 million tons, or 85.5%, were discarded in landfills. Economic and energy potential. In 2008, the price of PET dropped from $370 per ton in the US to $20 in November. PET prices had returned to their long-term averages by May 2009. There has been an increase in the use of plastics over the past few decades. This increase in use has dried up various exhaustible resources and caused a threat to the environment. Plastic is a unique material to be used in a broad range of products again and again. Plastics use oil and energy during its manufacturing. Nearly 4% of oil in the world is used to manufacture plastic. Though this amount is not very large, recycling plastic will save this extinguishable energy source. Consumer education. United States. Low national plastic recycling rates have been due to the complexity of sorting and processing, unfavorable economics, and consumer confusion about which plastics can actually be recycled. Part of the confusion has been due to the use of the resin identification code, which is not on all plastic parts but just a subset that includes the recycling symbol as part of its design. The resin identification code is stamped or printed on the bottom of containers and surrounded by a triangle of arrows. The intent of these symbols was to make it easier to identify the type of plastics used to make a particular container and to indicate that the plastic is potentially recyclable. The question that remains is which types of plastics can be recycled by your local recycling center. In many communities, not all types of plastics are accepted for sidewalk recycling collection programs due to the high processing costs and complexity of the equipment required to recycle certain materials. There is also sometimes a seemingly low demand for the recycled product depending on a recycling center's proximity to entities seeking recycled materials. Another major barrier is that the cost to recycle certain materials and the corresponding market price for those materials sometimes does not present any opportunity for profit. The best example of this is regarding polystyrene, although some communities, like Brookline, Massachusetts, are moving toward banning the distribution of polystyrene containers by local food and coffee businesses. United Kingdom. In the UK, the amount of post-consumer plastic being recycled is relatively low, due in part to a lack of recycling facilities. The Plastics 2020 Challenge was founded in 2009 by the plastics industry with the aim of engaging the British public in a nationwide debate about the use, reuse and disposal of plastics, and hosts a series of online debates on its website framed around the waste hierarchy. There is a facility in Worksop capable of recycling 60 to 80,000 metric tons a year. In Ireland, the rate of recycling is relatively low at only 37.4%. However, emerging technologies are helping to increase the recycling rates of items previously landfilled, for example mixed hard plastics. Plastic Identification Code. 5 groups of plastic polymers, each with specific properties, are used worldwide for packaging applications. Each group of plastic polymer can be identified by its plastic identification code, usually a number or a letter abbreviation. For instance, low-density polyethylene can be identified by the number 4, or the letters LDPE. The PIC appears inside a 3 chasing arrow recycling symbol. The symbol is used to indicate whether the plastic can be recycled into new products. The PIC was introduced by the Society of the Plastics Industry, Incorporated, to provide a uniform system for the identification of various polymer types and to help recycling companies separate various plastics for reprocessing. Manufacturers of plastic products are required to use PIC labels in some countries' regions and can voluntarily mark their products with the PIC where there are no requirements. Consumers can identify the plastic types based on the codes usually found at the base or at the side of the plastic products, including food, chemical packaging and containers. The PIC is usually not present on packaging films, since it is not practical to collect and recycle most of this type of waste. See also: Baylor, Bisphenol A identification in plastics, an article on BPA, ESP. Relevant to types 3 and 7 plastics. Microplastics, phase out of lightweight plastic bags, Plastics 2020 Challenge, post-consumer resin sterilization, reuse of water bottles, references. European Commission's funded FP7 Project Prime on mixed plastics recycling, external links, West, Larry. Recyclable plastic, why are so few food containers made of recyclable plastic? About.com. Retrieved May 4, 2009. Plastic packaging resin codes data from the American Chemistry Council, ISF's Plastics Recovery Manual, American Chemistry Council Statement on Plastic Recycling, Technology for Plastic Recycling, Mike Biddle. We can recycle plastic. Visit Earth 9/11 to find locations to drop off plastics that are not recycled by your municipality.